All right, guys, so welcome to the review for quiz 6. Hopefully you've already tried the problems, and I'm here to answer the questions and go through them with you. So first of all, this chart, you have got to know these formulas or you will really struggle to find these various angles. So it's all about where the vertex of the angle is. So the first scenario is if the vertex is on the center. I'm actually going to do the drawing first. So we're talking about an angle where it's actually on the center, so like that angle there. And then that if the vertex is on the center, then the formula is just that the angle is equal to that intercepted arc. So literally, this angle would be the same as that arc. Okay. If it's on the circle, so if the vertex of the angle is out here on the circle, then the angle is equal to half the measure of the intercepted arc. So again, it would be half of this arc there. Okay. If it's floating around inside the circle, so we're talking about a situation where it's not on the center, but the vertex is in the circle. So maybe something like this, and I want this angle. So it's not on the center like it was up here. In fact, usually if it's on the center, I'll give you that the name is circle M, so you'll know it's the center. So I'm looking for this. So first of all, this is the one where you have two arcs. You have the arc if you would go this way, which would be from here to here. And then you have the arc if you go the exact opposite way. So you have these two arcs. And the formula is that the angle is half of the first arc plus the second arc. So you add the two arcs together. And if it's outside of the circle, you have lots of scenarios, but one possible scenario could look like this. And you want this angle out here. And so we have two arcs that get intercepted. You have this larger arc out here and this smaller arc in here. And the formula is that the angle is half of large arc minus small arc. So those are the formulas that you need to know. I did also throw out that if you have the tan, which is like the party hat kind of situation, that this angle, you can still use large and small because the angle's outside, but this angle and the small arc are 180. So you can also use that as a shortcut. Okay, so you got to know these to be able to do the rest of the review. Okay, so then this is all about those scenarios. So the first thing that I would do is in this first one, I'm going to solve for angles 1 and 2, but it looks like for 2, I have, since it's floating around inside, I need arc plus arc. And so since I have the two arcs that go with angle 2, I'm going to do angle 2 first. So then that would be half of this arc, which is 70, plus this arc, which is 60. So I get half of 130, which is 65. So 2 is 65, and then remember its neighbor, 1, is just the supplement. These are linear pairs, so this would be 115. Okay. In number 2, the vertex is outside. When it's outside, it's 1/2 large minus small. So if I take a look at that, my large arc is here, and then my small arc is this guy from there to there. I know the large arc, so that's good. So I can do 1/2 of 160 minus, but to get the small arc, I need to find it. Well, the good news is I have all the arcs except that one. So I'm just going to do 360 minus those two, which is 290, and so I get 70. So that missing guy was 70. So then I have half of 90, or 45. Okay, in number 3, my angle is also outside of my circle. So I need to do 1/2 large minus small. So this is the small arc. This is my large arc. Again, I don't have the small arc, but I have every other arc. So I can just add them up to 360 and take that away to see what the small one is. So I've got 110, 180. If I add all those up together and take it away from 360, I get 70. So this last little guy is 70. So then I have 1/2 of the large arc, 100 minus 70. So I get half of 30 or 15 for that angle. Okay. In number 4, I can do the shortcut because this is a tangent scenario. So the small arc and the angle are supplementary. So it is 60. But if you didn't see that, since the angle's outside, you still have to do large minus small. But I have to get the large arc. So I'd have to do 360 minus 120, which gives me 240. And then I could do 1/2 large, 240, minus small, and I end up with half of 120. which is, guess what, 60, just like we got the other way. So it's your choice. If you want to use the shortcut of the party hat scenario, then you can do the supplementary. But if you want to go old school, you can. Okay, then on these guys, I actually gave you the angle and you have to solve backwards for the missing parts. So like in number 5, you have the angle that's floating around inside. Remember, when it's inside the circle, it's 1/2 arc plus arc. And my suggestion is always start with the formula. Then fill in what you know. I know the angle is 60. I know one of the arcs is 85 and the other one is x. Multiply both sides by 2 to get rid of the 1/2. And then subtract 85. And so I end up with 35 for x. And y, my angle's outside of the circle. So start with your formula. I've got 1/2 large minus small. And my angle is 40. And my large arc is x. And my small arc is 50. So then I've got, let's see, multiply by 2 to get rid of the 1/2. I got 80. I'm adding 50, careful. So I get 130 for x. And then let's see, actually you wouldn't be able to solve for y unless I gave you this, which I meant to give you. So I'll give you that now as being, let's do 100. So if this was there, sorry, it wasn't. If this was there, then you could solve for y. So you would have, let's see, we'd have 100. We now know x is 130, and we could add 50. So if I add those together, I get 280, and then I could do 360 minus 280, and I get 80. So y would be 80 then. Sorry, you need this to be able to solve. All right, in number 7, the angle's outside, so I'm going to do 1/2 large minus small. Or this is the party hat situation. So in that tan situation, these two are supplementary. So x would be 110, and then y would be everything left over from 360, so 250. If you want to do that if you did that the longer way, you wouldn't be able to solve this because you'd just have 1/2 x minus y minus x, and then so that's where you kind of had to use the tan relationship. Okay, in number 8, let's see, the vertex is on the circle. When the formula for when the vertex is on the circle is just half the arc. And the arc that I'm going to need for angle x is that mouth there. So it's this stuff inside, but I don't have that arc. The arc that I have is this guy, but this is everything else of my circle. So I can do 360 minus 280, which is 80. So that means that's 80. And then again, it's half of that. So I get 40. So the first part is to figure out where the vertex is and then decide what the formula is that you should be using. And then you just plug stuff into your formula. If you know the angle, then you're plugging the angle into the formula and solving backwards. Okay. In this second part, I'm giving you some shapes and you're solving. So the first thing I would do is this. I see a diameter, so I'm going to mark that so that I don't forget. Then I see an inscribed angle. An inscribed angle is always half of its arc. So I would have to double it. So this would be 70. And then check it out. These two things have to add up to 180 because they are that diameter, that semicircle. So x would have to be 110. So there I got x. This is a central angle because the vertex is on the center. So the arc is 130. And then again, this side has to add up to 180. So y would be 50. And then z is a central angle. So it's equal to the arc. So it's also 50. In 10, I don't have any diameters. Let's see, I do have the fact that I have this inscribed angle, so that means the arc that goes with it, y, is, let's see, double that, so 64, so y is 64. I can also use, let's see, I can use something a little sneaky, 125, and this angle would also be 125 because they're vertical, and then I'm going to solve this little triangle, so I can add the 125 and the 32 to figure out that last angle, and that last angle would be 23. So now that's an inscribed angle, right? Because its vertex is on the circle. So if I follow that out, that makes x double that, right? Because the angle is always half. So then that makes x 46. And that's helpful because now I have every single arc except w. So I can add 165 and 46 and 64. And let's see what we get. And I get 275, so then I would take that away from 360 to see what's left over, and I end up with 85. So that means this guy would have to be 85. So that took a little work. There's some other ways you could solve that, but that's the first one that I saw. You could solve for W if you wanted to. If you wanted to solve for W, you could use this little angle 125 because it's in the circle. So I could have used that the angle is half of arc plus arc. So if I use the 125, then the two arcs that create are this arc, 165, and then the arc going this way, which is W. So that's another way, and then I could have multiplied both sides by 2. This is another way that I could have solved for W. And so then I'd get W equals 85. Either way. Okay. In this one, we've got a bunch of inscribed angles, it looks like. So we've got this inscribed angle here, which is 58. I'm going to double it to get that inscribed, that intercepted arc. So that would be 116. Oops, I put that for X. Okay. And then I've got, let's see. If this is 102, I can get the last arc because they all have to add up to 360. So I got 142 for Z. And then this angle right here, X, if I follow it out, it intercepts 142, so it should be half that, so that would be 71. Now there is one thing I noticed I didn't put in the review, and I meant to, so I'm going to add that here. And that is what happens if you have, let me do that in black. What happens if you have a quadrilateral inside of your circle? And so what I mean by that is if I give you, your shape looks something like this, remember? And this is like 80, and maybe this is 113, right? Remember, and I did X and Y. This is the one where we said if your quadrilaterals inscribed, then opposite angles add up to 180. So 80 plus Y would be 100 then, and then X and 113 would give me 67. So don't forget that. That will be on the quiz tomorrow. All right, then we started doing chords and radii meeting. Remember that when you have a radius meet a chord, and it doesn't have to be the full radius, but if it's coming from the center and it's perpendicular, it bisects the chord. So that's the first thing I would mark. Then they gave me that AB, the whole thing was 30, which means each little part is 15. And then they want OC. Well, I have a right triangle where I have two sides, so I can do Pythagorean theorem. Or this is a triple. It's an 8, 15, 17, or you would solve it when you took the square root anyway. So either way, you'd get 8. In 13, again, I have this radius coming from the center. It's perpendicular. Well, it's not a radius, but again, it would be a radius if you kept drawing. But I have this segment coming from the center, and it's perpendicular. So it bisects this. If the whole thing is 16, then they're each 8. And then I want OD, which is the radius. That is a triple. It's a 6, 8, 10. But if you didn't know that, you could do 6 squared plus 8 squared equals X squared and solve, and you'd get 10. All right, in 14, I have this coming from the center. It bisects this side. Hopefully this is starting to stick. And then I have a 5, 12. This is 13. It is a triple. Again, you could do 5 squared plus 12 squared equals 13 squared. Okay, in 15, so in 15, I have this side, I have the radius is 25, and I need all of EG. Well, I can start by just using this little right triangle, which I have two sides. So once again, I could say 7 squared plus X squared equals 25 squared. Make sure you have the hypotenuse in the right spot. And I end up with 576, which is a perfect square. It's 24. This is one of our triples. But remember, EG is the whole thing, so you'd have to double it. So that would be 48. In 16, I have this side is 5. I have a segment coming, it is perpendicular, which means this little guy is also 5. And then they want OH. So again, I can set up my right triangle. And so I get 81 and 25 and X squared. So I do 81 minus 25, and I get X squared equals 56, square root. And I can divide that into square root of 4 times 14, which is 2 root 14 for OH. Okay, in 17, I have this side is 7, the whole thing is 14. Again, it bisects because it's perpendicular, so that's 7. And I can either use the fact I can do Pythagorean theorem and reduce, or this is an isosceles right triangle, which means it's a 45, 45, 90, so the hypotenuse is that leg times root 2. Oh, that circle should have had an O. Okay. All right, and then a couple more. We've got, in this picture, we've got that OJ is 12. They want JK. So you're going to have to make your own little one that's perpendicular. And then what that's going to do is split this into 60 degrees and 60 degrees for the arc. And remember, if this is 60, that makes the central angle 60. So then you have a 30, 60, 90 triangle. The side you have is the hypotenuse, so you can go to the short one across from 30 by taking half or dividing by 2, so that would be 6. And then that would make this side 6 root 3. So that whole thing would be that times 2, so 12 root 3. And then 19, I have OA is 9, and BC is what I want. So if this is 270, all of that, then this would be 360 minus 270. And that would be 90. So that whole thing is 90, which means each of these is 45. So that means this is a little 45-degree angle, which means guess what? This right triangle is a 45, 45, 90. You have the hypotenuse. So to go from a hypotenuse back to a leg, you have to divide by root 2. So then I could rationalize that. I get 9 root 2 over 2. And this side is equal to that because it gets bisected. So they're both 9 root 2 over 2. Okay. All right, in 20, I give you the chord is bisected. So if you know the chord gets bisected, then you know it's a right angle. So that's important because I know it's a right triangle then. And they want the diameter and then they want UG. So the first thing is if they don't have a radius drawn in, add a radius that makes your little right triangle. So my little right triangle has 9 and 12 and the hypotenuse. So again, I could do 9 squared plus 12 squared equals my hypotenuse squared. It is a triple. It ends up being 15. So first of all, remember, this is a radius. So if they want the diameter, you can just double that. So I get the diameter is 30. Now, if they want UG, this is the trickiest one. UG is this extra stuff out here. Remember, HG is a radius. And you already know that the radius is 15 because of this. So if that's 15, you could take away the 9, and that makes this little part 6. In 21, they give you KT is 16. It's perpendicular, so you know it gets bisected. Each one's 8. They give you the diameter is 20. Well, I can't use, there is no diameter to use in my figure, but the radius would be 10, and the radius is here. So I can fill the 10 in there, and then I can solve for MQ using Pythagorean theorem, and it ends up being 6. Remember, x squared plus 8 squared plus x squared equals 10 squared, or it's a triple, 6, 8, 10. Okay, and then last but not least, 23 on this type. In 23, I have, this is all 240, so I can do 360 minus 240, and I get that all of this is 120, so x is 120. And then again, when I drop this radius towards that, it makes that right angle, and it also splits this into 60 and 60. So this makes it a little 60, 90, 30. This actually might be the same. Is this the same problem? No, not quite. Okay, so then the hypotenuse is 9, right? And we need to go to the side across from 30, which is here, and I do that by dividing it by 2. So this side would be 4.5, 9 divided by 2. And then remember, to get the side across from 60, you multiply by root 3. So from here to here, just that little part is 4.5 times root 3, but then we want all of TK, so we'd have to double it. So we'd have to do 2 times 4.5 root 3, which gives me 9 root 3. Might have to watch that one a couple times. Okay, in 24 it says the chords are congruent, or are the chords congruent is the question. Well, if they're congruent, then the distance from the center has to be the same. This one's 8, so we have to see if this one's 8. So the first thing, that's perpendicular, so this gets bisected, so this is 15. I can use Pythagorean to solve this, or it's a triple. It is in fact 8, so you would say, yes, they're the same distance from the center. In 25, we know the chords are congruent, so if we know they're congruent, then we know, first of all, these two things are equal. That gets bisected. That has actually nothing to do with them being congruent, but we know that that's true. So I can solve for x. I get 4. And then if that's 4, then I can plug in x equals 4 here. So 2 times 4 is 8, minus 5 is 3. So that length is 3. So how much is MP? Well, if the chords are congruent, then their distances from the center have to be the same. So that would make this 3. And then the question is, how much is the radius? Well, first, we need a radius. We don't even have one. And remember, you want to draw it so there's a triangle. So I'm going to use this little guy. I already know this side is 3. This side I can get by plugging in x. So 4 plus 8 would make this side 12. And then I just need to solve for this missing side. So I'm going to call it y. That's the hypotenuse. So make sure you do 12 squared plus 3 squared equals y squared. So then I've got 144 plus 9, which gives me 153. And that is, there's nothing I can do to simplify that guy. So he's just going to be square root of 153. So sometimes you have to draw that radius in, guys. Sometimes you don't have it, but it always should create that right triangle. Okay. All right, so then last but not least, we were solving for missing angles. So I said always label, if there's a diameter, label it. So there is, AB is a diameter. So do the little arrow thing. Then fill in as many of the missing arcs as you can. Hopefully that's all of them. And then solve. So like, okay, this side has to be 180, which means x is 70. And this side has to be 180 because of the semicircle, so that means y is 50. Once you fill in those, you can get any angle you want. So let's find it. Angle 1. Well, the vertex for angle 1 is on the circle, so that should be half the arc. So the arc for angle 1, if I follow it out, is 110. So I would take half of 110, which is 55. Okay. Angle 2. Angle 2 is here. Angle 2 is also on the circle. Follow it out. It intercepts this arc as well. So it's also half of 110. Remember, when the vertex is on the circle, it's just half the arc. Angle 3 is also on, its vertex is on the circle. Follow it out. It intercepts the arc of 50, so it would be half of 50, so 25. Angle 4, also an inscribed angle. Vertex is on the circle, so follow it out. That's also the arc 50, so half of 50 would make that one 25 as well. Okay. How about angle AEC? AEC. That's this angle here. If I want that angle, well, that's floating around in the circle. It's not on the center, but it's in the circle. So that's when I have to do 1/2 arc plus arc. So I need the 2 arcs. So go this way. This arc is 70, plus go the exact opposite way. That whole arc is 130. So I'm doing half of 200, which gives me 100. And then how much is AED? Well, again, if you're smart, you could say, oh, well, if this is 100, AED, which is the neighbor, should be a linear pair. So that would mean AED is 80 because they should add up to 180. Okay. Next guy, we're going to do the same thing. Let's see. Circle W, we do have that this is a diameter, so we're going to mark that. We know that arc XZ is 60, and we know that angle VYZ, this angle right here is 40. Well, that's an inscribed angle, so the first thing I would do is get the arc, which would be double that, so 80. And then you have your diameter, so fill in the missing arcs. This little guy, all together, that's 180, so this guy would have to be 120. And this half is 180, so that would make this guy 100. Once you have all those arcs, you can solve for the rest of this stuff. Okay, angle XYZ, or excuse me, XYW. XYW. That's this angle right here. That's on the circle. Follow it out. 60, so it's half the arc. So that would make that 30. Let's do this one. XWY. XWY. That angle has its vertex is on the center. When it's on the center, it's equal to the arc. So the arc is 120. So the angle's 120. Arc YXZ. This is the arc. Y through X to Z. Well, that's a full semicircle, so 180 degrees. How about VZY? Angle VZY. That's this angle here. That's on the circle, so it should be half the arc. Follow it out. It intercepts the arc of 100, so that would be half of that, so 50. WXY. WXY is this angle. Now this one's tricky because it doesn't go all the way to the edge. So you're going to have to use the angles inside. So like, let's see, we already found this angle. This angle was 30. So I'm going to fill that in to help. And this angle we said was a central angle, so it was 120. So you can add these up to 180. So if I add those two together, I get 150. So that means that angle must be 30. So sometimes you do kind of have to use your little triangles and stuff. XWZ. XWZ is a central angle because it's on the center, so it's equal to the arc, 60. You could have also used that it's linear to this one, so it had to add up to 180. And then YVZ. YVZ. YVZ is all of that. And so that's on the circle, so I need the arc. So if I follow it out, that gives me this, which is 180, but it's on the circle, so it's half. So that would be half of 180, so 90. Okay, and then we have one more, I think, and we're done. Okay, so in this last one, again, label the diameter first, so you know where the 180 split is. Label what's given. AB is 64 degrees. ED is 78 degrees. CD is 84 degrees. And FE is 56 degrees. Okay, so because of the diameter, this side has to be 180. So I'm going to add 64 and 84 together and take that away from 180. So I get 32 for that guy. And then this side has to be 180. So I'm going to add the 78 and the 56. And I get the missing one is 46. Okay, so I could have asked you to solve for all of these angles, but I just picked a few. So angle 1's vertex is on the circle, so it should be half the arc, so follow it out. It intercepts 84, so half of 84 was 42. Angle 18 is in the circle, so I have to follow it out to the two arcs. This arc, 46, and backwards, 32. So I would do half of arc plus arc, 46 plus 32. So I end up with half of, what is that, 78? So half of 78 gave me 39. Angle 9. Angle 9's vertex is on the center. It's a central angle, so it should be equal to the arc. So follow it out. That arc is 78. 5. 5's vertex is on the circle, so it should be half the arc. So follow it out to its arc. That would be 64, so it's half of that, so 32. 11. 11 is in the circle, floating around inside, so I have to do half arc plus arc. So the two arcs, follow it this way, 78, and follow it the opposite. The opposite is all of that, right? So it's 78 plus all of that together, which is 96. So it's half of arc plus arc. And so we ended up with, let's see, I got 87. Okay. And then 16 is also inside, so I'm going to do arc plus arc, half of arc plus arc. So half of go this way, this arc is 64, that way 84. And so I end up with half of 64 plus 84, which is half of 148, and that is 74. The only one that wasn't in this drawing was one that was outside of the circle. And I would be prepared to see ones that are outside of the circle. So, 1/2 large minus small and such. Okay. And I think that's it. Again, the only one that I didn't really put on there in general, just to review one more time, is the one where you might have a quadrilateral inside of your shape. Don't forget that the opposite angles in a quadrilateral do in fact add up to 180. So if you know y, or I'm sorry, if you know this is 87, then you know that y would have to be 93. And if you know that this is 123, its opposite angle x would have to be 57. So just remember, this is when you have a quadrilateral inscribed, right? Okay. All right, good luck. Again, it might take a couple of times of watching this so that you're ready for tomorrow's quiz. You can definitely do it, but you got to know those formulas and those rules, especially with the chords being perpendicular and bisecting and the same distance from the center and good stuff like that. So make sure you're reviewing all those ideas. I'll see you tomorrow.